So good morning all, and today we are going to be starting with actual lab program prescribed for 6th semester computer science engineering and branch, and the subject system software and operating system, right? And last two different sessions we are discussing basics of what is system software, compiler design and operating system, and what exactly the basic syntax to be designed in order to implement your basic Lex and Yak programs, and basic syntaxes related with an application oriented programs, right? And today we're going to be start with actual lab set of programs that are included for your practical session, right? So lab consists of totally 9 different types of programs, and each program is having their own advantages, application usages, and again in terms of an subject we'll be discussing what exactly that phases of the compiler and how that phases of the compiler is going to be process the logic, and how the sequence of execution is going to be implemented. And then we are going to be shifting towards operating system, what exactly operating system, how the scheduling algorithm is going to be described. Everything you are going to be discussing within total 9 set of program, right? In the first program you will be writing the lex, and you will be identifying for arithmetic operations valid or not based on the operators, and you're going to be printing what are the total number of operators are available, whether identifiers or expression is going to be valid or not. That is the first A question. And in the first B question, second sub question with the first question, you'll be implementing Yak program to evaluate the arithmetic expressions, right? When you're writing the program, we'll be writing mathematical expression and we need to evaluate that expression, right? Evaluation is basically defines if you want to add some data, so constants will be there. For that constant, user has to add some integer values, and based on that some operators will be evaluating whether arithmetic expression is valid or not. That is your first sub program 1b, right? In the second program, it's an implementation of Yak program, but again it is an automata theory or finite automata concept, just for identifying some grammar in the form of a to the power of nb, right? So based on that grammar a to the power of nb, we'll be implementing an Yak program. So Yak tool we are going to be identifying and verifying whether that string is going to be valid or not based on an input a to the power of n as well as b, where n is going to be the given value. If n is equal to 1, then ab will be there. If n is equal to 2, 2a followed by b, means always strings is going to be ended with unique b or a single value b. So that is your second question, right? And number 3 is your design and implement Yak or C program to construct a predictive parsing. So that comes in module 4th, and we have already discussed basics of parsing, types of parsing, and how the parsings are going to be integrated based on the grammar, right? So based on the given grammar, we'll be creating the parse table, and we'll be evaluating for a given input string abb followed by dollar. That's your program number 3. And in the fourth program, another type of parsing you're going to be predicting it, that is a shift reduce parsing. So again that comes in module 4 theory concept, and again it is having some basic rules. Arithmetic expressions will be given. Based on the arithmetic expression, we need to evaluate for the string or a statement or a statement sentence id plus id followed by id, right? And the fifth question is your intermediate language, or we can call it as a mnemonical representations. So some set of codes will be given, and for that basic code we'll be performing some intermediate code generation as a machine code. Either you can represent it in C program or Java program. So based on that particular program, output is going to be identified, how that intermediate codes or address formats are going to be generated. That comes as your fifth program, right? And sixth program, again you'll be implementing Lex program to identify the comment lines, and again you need to copy it into separate file. That's some unique command you are going to be using it. And sixth b, you are identifying with an valid operators, keywords, identifiers in a given C program file as an Yak program, right? And 7th, 8th, 9th is your operating system concept that depends on scheduling algorithm, and again deadlock concept, how the bankers algorithms are implemented and safety of the particular status of an algorithm. And the ninth one is your page replacement. So that we are going to be implementing with list replacement, list recently used, along with that first in first out, right? So all the 9 programs you can use it with an any type of system softwares like Flex, Bison, or any interfaces it is that is available in real time, or any simulator tools will be available in online. You can execute anywhere based on your operating system requirements. Either you can work it with a Windows operating system, or you can work it with an Ubuntu operating system. That depends on user, right? And now we'll go for actual first program of syntax, and how we are going to be executing the programs. Okay, So actual app program. So write a Lex program to recognize a valid arithmetic expression, identifies an expression, and how could be that only integers and operators will be available, and you need to count that operators and print them separately in your program, right? And as we know, any Lex program, it consists of three different types of syntaxes. So when you're writing any program, syntaxes and semantics plays an important role. It is having some protocols, it is having some functional syntaxes. So user has to represent the program in the same pattern what exactly that syntax is going to be defined, right? As we know, in the first block of the lexical program, we are having a declaration section, right? And nextly we'll be having definition section, and nextly we will be having main section. So, and in the first section we'll be declaring some variables of the integer data type, and again in the definition section we'll be giving action and role pattern. We are going to be defining it, so that pattern what exactly to be matched, right? So basically identifiers are going to be matched, so sequence of characters will be there, plus specifies one or more occurrence followed by any number of values will be there. So that situation identifier is going to be updated. And same thing if you want to identify an operators, according to this example we are considering the operators like plus, minus, star, division followed by equal. These are all the different operators. Again OC++ stands for operator count, and TC++ stands for total count. So both will be incremented. And again in expression, sometimes we'll be writing that braces will be there, simplified braces or a curly braces. Any process of logic you can include it for your particular program. So based on this logic, your program is going to be axis, right? Same thing if your Java program, when you're writing import java.io dot star semicolon, that is a sequence. That's the rule we have to follow it, and hence that rule is going to be already defined in your compiler. So what rule you are going to be defining, that rule is going to be agreed when you're executing your any sort of programming languages, right? And nextly followed by main method. So main method is an actual execution of your Lex program is going to be begins, and you'll be entering the expression, then you're calling the function, special function of executing your all Lex program by using a special function called it as yylex. And next you'll be calling the yylex. As we know in the declaration part, what declaration rules and again what exactly that actions will be given, everything is going to be matched. And based on that, once yylex is activated, it will check with the variable declaration along with the corresponding rule, and action is going to be added. Once it is identified, then you'll be taking that iterative statement or branching looping construct concepts to identify whether that expression is valid. And again if it isn't valid, you will be checking how many operators will be there, how many operands will be there, and everything you are going to be executing it, right? And total identifying count you'll be doing with an IC, and operator count you'll be doing with an OC. Then total count of both identifier and operator will be represented with an TC, right? If expression is invalid, in case if user is given some invalid, then it will be predicting as output is invalid. So here we have some sample output after the execution of your first lab program, right? So how to compile the Lex program? So basic syntax of compiling Lex program is Lex space filename dot l, right? And always try to give it a meaningful file name. Don't give any complex or any special characters to be included for your file name. Just I given 1a.l. And then afterwards, to compile that particular program, we are using compiler called it as gcc space lex.yy.c -ll. -ll stands for link the Lex libraries. Everything is going to be attached for your program. So in case if you're having any compiler error or any runtime error, it will be generates an error, or else you can directly run the program by using /a.out as a command. Next you'll be entering an expression. Assume you'll be entering an expression a plus b, and after entering an expression you'll be entering a control T, or if you directly had the data over there, then identifiers will be entering a count 1 will be there, and the operator counting is plus, again count 1 will be there, identifier will be like that. All the expressions will be identified, then total identifiers in a given expression, total operators in a given expression, and combination of both will be taken as a total count. So this is a first basic example in your lab program how exactly Lex program is going to be implemented to verify the valid expression and counting that identifier, operator, and its total count, right? Next we move on to second program, that's the first sub program B1b, right? So write a YAC program to evaluate arithmetic expression involving that operators plus, minus, star along with a division operator, right? As we know that whenever you are writing that YAC program always takes an input from your first phase of your compiler, lexical part, right? So lex part is mandatory to implement your any YAC programs. Sometimes the question will be given, write Lex and YAC program to evaluate arithmetic expression. It's completely meaningful question, but sometimes they'll not specifying Lex syntactical syntax in the program. So that time if user has to write with an lexical part, without the lexical part user cannot write it with an YAC application programs, right? So just I'm going to start with the Lex part. As we know 3 sections will be there, just I'm taking with a declaration section, or we can call it as definitions will be given. Any variable declarations with definitions, everything will be there. And next will be action and pattern rule sections will be given, then followed by your yak part will be there. So here we are not calling the main method in lex part, because yak part is a main, where exactly the yak part is going to be takes an input from your lexical part. That's the second phase of your compile. In yak part again we are having three different sections. So first section is always going to be the declaration definition. Then again, if you're connecting a tokens, very important, this part specifies tokens, how many tokens you're taking from your lexical part, because where the first phase of the compiler takes the source program and always it generates in tokens. The token is going to be collecting by your yak program, and the tokens will be number, and tokens will be left associated with the operator plus and minus, left associated with the operator star followed by division. Next followed by rule section corresponding action. So if any expression, again it will be depends on the expression what you are going to be given, and again I am be checking with an verification of the particular expression. So I am taking exp, it's just a rule section in terms of a context free grammar. Exp colon exp plus exp, that specifies dollar dollar equal to dollar one plus dollar three. That so dollar specifies the variable of your given program, right? Or expression minus expression means dollar dollar equal to dollar one minus dollar three. Like that you will be specifying and identifying within all types of expression validations in a given program. And lastly you will be terminating with an 2% symbol. Now you will be calling int error method in case if your program is terminated, if you want to terminate the program, so that time this function is going to be executed. So that is int error. If in case terminating or if any errors are occurred, for that purpose we are using this method, right? And next we are calling with the main method. So once if you have taken a void main method or int main method, so we will be entering an input first statement, expressions will be entered, then we are calling parse. So what is parse? Parse is a method which is used to start executing your yak program. But once if you start executing a yak program, first it will take it and collects the tokens from your lex program, then it is going to be processing with an yak syntax, right? Now we'll look on how the syntax to be implemented if you want to compile both the programs. In the first A program we are compiling only lex program, but in the second program, that's a 1b program, we are compiling both lex and yak. So what's the syntax? So as usual, common syntax for lexical program, lex space filename.l, and for compiling your yak program, yak -d, a file name followed by .y syntax. What the purpose of -d? -d is represents a defined tokens. What are the tokens that are going to be defined? That is going to be collected. So once both the file has compiled, next step is to identify any syntactical error. So gcc lex.yy.c is the file generated from the lexical program. y.tab.c is a file generated from yak program. Then link the library and link the yak file. So both has to be connected. If in case there is no error, you'll be there in the programs, directly run the program with the syntax /a.out. And again you are giving an input, enter an expression a plus t. So once if you enter an expression, directly it will give an error syntax. Reason is nothing but here we are not verifying an expression. If you are verifying an expression, this is a valid statement, but here we are evaluating an expression. Evaluating an expression means that input should be always integer value. I cannot take other than integer value. Hence that first output is representing error statement. But check with the second one, ./a.out, enter an expression. If I enter 2 plus 3, and if you want you can take with the braces, if you want you can take with the multiple operators, priority of an operators. So each and every statement you have to verify it for a particular program, for an applications, right? So 2 plus 3 means obviously the output will be generated as an 5. So this is the first two sub questions of your program, 1a and 1b. Next we move on to second program. So what is second program defines and second program objective? The second program is going to implement a yak program to verify the sequence of string a to the power of n and b. So we are just implementing what exactly that automata theory, DFA representation, regular expression representation, how that grammar is going to be validated, on what basis that grammar is going to be verified, the string is accepted, right? And again it is an yak program directly specified in the question, but user has to write a lexical program. So without lexical program, the output of the lexical program has to pass to input. Hence yak program always going to be implements lexical program, right? And the lex part, as we know, the declarations parts will be there, then followed by pattern rule sections will be there, and a value will be given based on the return value will be a, and b value will be given based on return value will be b. Means just we are correspondingly identifying in grammars. Grammars is going to be identifying for a given input a to the power of n followed by b, right? And slash n represents your new line character that will complete your lexical syntax, so that tokens are going to be generated, right? And according to this example, observe here, only 2 tokens we are going to be collecting it. But in the two previous program, again we are going to be collecting number. So number is the only token we are going to be collecting. Apart from that, operators, keep it in mind. So we are not collecting any character, that's why it is an error statement. Number has to be collected, and again operators has to be collected. So only two different types of tokens are going to be collected from the previous program. Same thing in this program, we are taking two tokens, return a followed by return b, and next line specifies there is no input of a given string, right? And next comes with add part. Again declarations will be given, standard input output IO, then again standard lib dot h header file. Then only two tokens are going to be collecting from the YAC program, so from the lex. So token followed by ab. Now you're going to be taking an input and you'll be printing successful grammar. When you are printing successful grammar, if you're having a string a to the power of n followed by b, so if I consider any string a to the power of n followed by b, 1a 1b will be there, 2a 1b will be there, 3a 1b. Always strings is terminated with a single b, so that is an accepted string. So for that we are going to be writing in this syntax, AS1B or BS1 or followed by AS1. Each and every time we are deriving a new string and we are verifying whether the string is valid or not. So this is your logical process of your YAC part. Next we will be calling main method, and again in the main method I'm entering with the string, then YY parse means it is going to be call your YAC program that is going to be collects the token from the lexical program. Then afterwards it will verifies with the rule sections corresponding pattern, then it is going to be identifies particular output. And YY error method, if any syntactical error, if other than that valid statement, then YY error is going to be processed, right? So we'll now check with some sample output for the given program, second program. So just compile the first lex program, then followed by compile a YAC program, and combine together with the compilation gcc space lex.yy.c space y.tab.c, link the library lex library and link YAC files. If it is in no error, directly run the program with the /a.dot command, right? So here I am entering the string aab. So as we know, a to the power of n b means any number of a followed by b, so that is a valid string. Same thing if I enter a string BAA, again it is an invalid because B is a terminal string, but here B is started initially, then later A is going to be terminated, hence it is an invalid string, right? So this is just an example how automata theory or finite automata is going to be implemented for a regular expression representations or deterministic finite automata representations, and how the transition is carried out from one state to another state. That is your program number 2. Right. Next we move on to program number 3. So the program number 3, as I told in introduction, beginning of introduction, either you can implement YAC program or you can implement with the C program, just in order to construct a parsing. As we know, parsing is nothing but second phase of the compiler. It will generate a parse tree based on the token given by your lexical program, right? And the grammar is given, a2 tends to aba and b tends to bnb followed by terminal symbol epsilon. As we know, uppercase always represents a non-terminal, lowercase always represents a terminal, right? Now we look at with the C syntax. Just I'm going to adding with an to header file hash include stdio.h and hash include string.h. Then we are going to be starts with the main method, right? And basic character data type you are going to be defining with the different variables fin of 2 dimension 10 and 20, then st of 2 dimension 10 and 20, then again ft of 2 dimension 20 and 20, then followed by 20 as well as 20. Now some integer variables we are declaring. Ea is equal to 0 with initialization, ei tb cn kl, then js mp. Some local variables we are going to be declaring it within a main method. Next, enter the number of coordinates. So user has to enter a coordinate. So coordinate is nothing but integer value based on your n input. After entering that coordinate value, then you are entering with a production in grammar. So how to implement productions in grammar? For example, if I'm having a symbol a to the power of n followed by b, so the productions can be represented based on the given grammar, and based on that grammar we will be generating a string, then finally output is going to be identified, right? So once if we entering the productions in a grammar, we need to check, we need to scan each and every statement of your given program. So just I'm taking an input based on the iterative statement, then I'm going to be checking whether that given data is valid or not, or it is terminated or not. Each and every flow you are going to be checking it. And next, within the for loop iteration, just we are taking within two nesting for loop, one with a s index variable, another with an I index variable, right? So two different variables are going to be generated. Then by using a labeling concept, by using a labeling concept, we are going to be terminating the program based on the logic what we are going to be executed. So some data we are going to be taking it, some input we are going to be taking it. So then based on that value, user is executing. As you can see, 64 followed by 91. So what that specifies an ASCII value. So the particular ASCII value is going to be generated. So input is going to be given, based on the inputs are going to be processed, right? And followed by, you will be checking with an if condition. So that's a branching statement, conditional branching. So based on the condition, it will be using a comparative statement, then go to S1. So label name, you are going to be taking it as S1. Then again, you will be checking with an I and j value. Then you will be incrementing with n value. Then again, you will be checking with step 1. So control directly comes to go to if in case this condition is not valid. If it is valid, if not valid, control directly comes to this statement. If it is equal, assigning the values, it's a comparative statement, then again it is going to be shifted to S1. So S1 is going to be there, or else if condition is fails, it executes with a second false block of your statement. And each time you'll be checking with all the symbols are going to be identified, and based on that symbol, inputs are going to be processed, right? And once if you identify the first positions, you are going to be collecting it first and follow. As we discussed in theory class, a tends to a will be there. What is the first of a? So first of a means I can find out with terminal a, or I can find it with non-terminal a. So terminal means smaller case, non-terminal means uppercase. So first positions you have to identify. Then again follow positions, which are all the members you are going to be following it. So after which terminal, next terminals is going to be identified. So each and everything you are going to be editing as a first and follow algorithm for your parsing technique, right? And later we'll be checking in the same syntax. So application wise how that it works, and just I'm just giving with the execution flow. So vam 3.c will be given, then gcc 3.c, then again dot slash a dot out. So enter total number of coordinates. So just I'm entering with the 2 coordinates, right? After 2 coordinates, you need to enter the productions in grammar coordinate system values, and assume that input is given in the form of grammatical a tends to ab and b tends to bb followed by hat symbol. Then you need to calculate first and follow. So what is the first of non-terminal a? It is an a, first character that is available for a. And first of b, again b or at symbol. The same thing follow of a. So what is following for an a? Nothing is following it, hence it is a dollar. What is the follow of b? Nothing is following, hence it is going to be represented as follow of b is represented with as a. Check with your b after a is available, but a after nothing is available. Very important, right? Check nextly a of a. So from a of a, what are the different sequences we can find? ABA we can find, b of b you can find with b and b, and b of a, b tends to a. There is no symbol, hence I can directly take it as at symbol, right? So next we will be checking with 3 different coordinates. So what is the 3 different coordinates? 3 different grammars we are going to be writing it. A tends to ABA, at or B tends to BA, followed by CA, then C tends to C. So what's the first of position A? First of position A. So A is going to be corresponding with A, or at first of B means B followed by C, B followed by C, and again it can directly take it with an following that particular value with a particular input, and later follow of each character. So follow of A is going to be dollar, follow of A is always equal to A also, then follow of B, B after A is available, since A can be replaced with A, hence after B terminal A is going to be available, then C followed by A is going to be available. So this is how based on the coordinates the first and follow is going to be identified. So each and every value is going to be compared with the grammar, then all the data are going to be verified, right? So today we are going to be continuing with the next program, fourth program, that is a continuation of your program number 3, that is an LL1 parsing. Now it is going to be shifted is parsing, right? So same program, but grammar is different, technique is different, and again we are using different grammar tool. So just I am implementing with the C syntax only. Either you can implement with the YAP program syntax, or either you can implement with a C program syntax. So as we know, with the program C syntax, we are having an header files, then we are declaring global variables kz, I, j, c, and again we are declaring a character variable. Then just we are defining a global declaration of a method called it as void check function. Next, void main method. So grammar we are going to be taking as a printf, then printf we will be taking enter the grammar, read method will be taken, and the read method is going to be added with an a variable, that's a one-dimensional character array. Then that value is going to be stored it with c. Next, I am performing string copy method. According to Unix command, strcpy is going to be taking the data and put it in a hacked source to destination. Then again you are going to be printing it the data in the form of stack input followed by action. What's the stack content, what input you have taken, what is the corresponding action, that has to be printed in your programming syntax, right? And next we are going to be taking a looping construct, for loop construct, and for loop construct we are going to be checking it for a conditional branching statement if, and then that values are going to be easily copied from a of ij to stack of I, and each value is going to be correspondingly checked within all the inputs. Similarly, we are going to be comparing with all the characters in a given string, then I am going to be calling with a check method, right? So once check method comes, it is going to be reducing it is going to be copying, and then it is reducing a given string into corresponding input, and each and every time you will be checking the top of the string value and what values to be incremented. Everything is going to be identified with the same syntax. And again nextly you are going to be having with the same set of looping construct and same set of branching statement with a different input, and each time you're going to be comparing the value, and again you'll be updating with all the sequence of logic of the program. Now we look on with how the executions can be implemented for the fourth question, yak followed by the shifted using parsing technique. So same process will be given. Since it is a C program, the compilations will be represented as gcc space filename dot extension dot c. Nextly, we will running that program dot slash a dot out, and then the grammar is going to be represented e tends to e plus c, that's a printf statement, and input string will be given as id plus id star id. So the stack representations id will be given and input will be given, action will be taken. So according to given process, according to given logic, id is going to be taken, but what is the remaining data is available in the first step, plus id star id. So what is reduced, what is going to be shifted or reduced means the values are shifted, the values is shifted to stack first value, and nextly that value can replace, id can be replaced with e, directly you can enter with an expression value. Next, remaining input available is plus id star id followed by dollar. Now here I am just reduced to e, what identifier is available, that we are going to be reduced it into e. So that is a given input process. Afterwards, next input available in a given input is plus, the plus will be added to stack, and again it is a symbol, you need to shift a symbol, so symbol has to be shifted. And nextly we are having an input called it as id, so it is going to be shifting an id, and nextly id is going to be replacing to e, that is a reduce e to e, then again e plus e will be reduced to e, that's a common value, so again it is going to be reduced to e. Then again next input is going to be star, so available is symbol, and again it is going to be shifted, and next input we are going to be added for a stack, and later all the data are going to be added, empty is going to be data available, that's an empty of the string or end of the tree, then output is going to be generated, right? And id star id, how the shift will be done, reduce will be there. So each and every input you have to cross check, and you have to identify for an different types of validity for an both program number predictive parsing and again shift reducing parsing, right? So thank you for watching the first set of lab programs, that is a part 3 video on system software and compiler design and operating system lab. So next we completing with the next lab set of programs in the next upcoming classes. Thank you for watching, and if you have any comments and any feedback and queries, please kindly revert back in a YouTube channel. So thank you for watching it.